Well, this video is for Math 70. I'm going to go over the problems from sample test number 2. Your test, the actual test, will have the same number of problems. It'll have the same types of problems, but different problems. Let's see. For problems 1 and 2, those are graphing problems, so I'll make a little grid here. You'll have grids on your test paper, so you won't have to worry about that. The one thing you do need to do on your graph is to indicate the scale on your grid. Okay, so problem 1, graph the following equation, and the equation is 5x minus 4y equals 16. So I'm going to put this into slope-intercept form. I'm going to get the y by itself. So let's move the 5x to the other side. Don't lose this negative sign. That's a minus 4y equals minus 5x plus 16. And then if we divide everything through by negative 4, we get the y by itself. This will be positive 5/4 x minus 4. And if you do negative 5 divided by negative 4, you'll get 1.25, which is not wrong, but I find it's a lot easier to graph if we keep the slope as a fraction. So our y-intercept is here at negative 4, and then we can go up 5 and over 4, and up 5 and over 4 again, and the line will look something like that. Okay. That's problem 1. Let's see, problem 2 is another graphing problem, so let's clean this up so I can use it again. Okay. So, problem 2, we need to graph, let's see, 3y plus 2x equals negative 9. So again, I'm going to get the y by itself. So I'll subtract 2x on both sides. 3y, negative 2x minus 9. And then divide everything through by 3. Y is negative 2/3 x minus 3. So in this problem, the y-intercept is negative 3. And with a negative slope, if I go up 2, I have to go back 3. Up 2 and back 3, or I can go down 2 and over 3 to the right, and that gives me the negative slope. With the negative slope, right, if you go up, you have to go back on the x's, or if you go down on the y's, you can go to the right on the x's. So that's problem 2. Alright, let's see. Problem 3 is about the x and y intercepts. So, problem 3, find the x and y intercepts for the given equation. This one is 5x minus 4y equals 20. So the x-intercept, that's the point where the y is 0. So we just put in 0 for y. That gives us 5x equals 20. And x equals 4. So the point that we're interested in for the y-intercept is where x is 4 and y is 0. Alright, the y-intercept, that's where x is 0. And so that'll give us negative 4y equals 20. And then divide on both sides by negative 4, y is negative 5. So the point for the y-intercept is where x is 0 and y is negative 5. Alright, so that's problem 3. Let's see. Problem 4, we need to find the equation of a line given 2 points. So, in problem 4, let's see, we want to find the equation of the line that connects the 2 points negative 2 and 0.5. and 7, 5. So, along with the test, and this will be with the sample test as well, you've got these formulas here. Mostly it's just the slope formula, okay? And that is m equals y2 minus y1 over x2 minus x1. So, if we want to find the equation for this line in problem 4, first we need to find the slope. So, let's see. I'll start with the 5 on top minus 0.5. And then if I start with the 5 on the top, I have to start with the 7 on the bottom. These two minus signs come from the formula. This minus sign will come from the value of x in the problem. Okay? So on the top, we'll get 4.5. On the bottom, 7 minus negative 2 is 7 plus 2, which is 9. So here our slope is a half. You can call it 0.5 if you prefer. All right, so our line is going to be in the form, the equation will be y equals a half x, but we don't know the y-intercept. It's going to be a half x plus b. To find out what b is, we'll plug in the x and y values here. So the y is 5 when the x is 7. You can use this point as well, but you have to use corresponding x and y values. If I use the 5 for y, I have to use the 7 for x. I can use 0.5 for y, but then I would have to use negative 2 for x. Either one will give us the same answer. Okay, so over here, a half times 7 is 3.5. Subtract on both sides to get the b by itself, and b turns out to be 1.5. So the equation of the line that we're looking for, y equals a half x plus 1.5. And if you want to call the slope 0.5 instead of a half, that's fine. If you want to call the y-intercept 3 over 2 instead of 1.5, that's fine too. Okay? All right. That's problem 4. Problems 5 and 6 are those parallel and perpendicular problems that we talked about last week. So let's see. Problem 5. We want to find the equation of a line that is parallel to the line 3y minus 2x equals 8. And we want that line to pass through the point 6, 1. Okay. So, in this problem, if we want to find a parallel line, we have to know something about the slopes, okay? Because the slopes of parallel lines are the same. So first off, let's look at this line. If we get the y by itself, we'll be able to find out what the slope is. So 3y minus 2x equals 8. Add the 2x to both sides. 3y equals 2x plus 8. And then divide everything through by 3. So there's the equation of the first line that we're working with. Now you don't have to graph anything or draw any graphs while you're doing these problems, but I'm going to draw one just to remind everybody how these problems work. So this line is 2/3 x plus 8/3. That'll look something like this, okay? Now, we're interested in a line that passes through the point 6, 1, which is going to be about right there. And we want it to be parallel to that first line, like that, okay? So, this purple line is what we're looking for. We've got the equation for the green line already, all right? So again, if these lines are parallel, they're going to have the same slope. So the purple line that we're interested in is going to be in the form y equals 2/3 x plus b, and we need to find out what the y-intercept is. So to do that, plug in the 1 for the y and the 6 for the x. Let's see, 2/3 times 6 is 4. And then get the b by itself. Here b is equal to -3. So the equation for this line that we're interested in is going to be y equals 2/3 x minus 3. And that's the equation for this purple line right here. And yeah, it looks like we've got a y-intercept of -3 down there. Okay, that's problem 5. Let's see, in problem 6, we're going to be looking for a perpendicular line. So, problem 6, we want to find the equation of a line that is perpendicular to y equals -1/3 x minus 7 and passes through the point where x is 3 and y is 10. So again, you don't have to draw any graphs or anything, but I'm going to draw a graph to remind us how these problems work. So this line, this equation right here is slope-intercept form. We don't have to change it around or anything. The slope is right here, and there's the y-intercept. So at -7 with a slope of -1/3, it's going to look something like this. Now we want a line that's going to pass through the point 310. Let's see here. So that's going to be like here, and then up here. And we want it to be perpendicular to this line. So it's going to do something like that. And there's that 90-degree angle that shows that they're perpendicular. So we need to find the equation for this purple line. Now, with perpendicular lines, their slopes are negative reciprocals. So if the slope for this one is -1/3, the slope of the line that we're interested in, the purple line, is going to be +3/1, or just 3. We can call this just y equals 3x plus b. And then again, to find out what the value of b is, we'll plug in 10 for the y and 3 for the x, and then get the b by itself. B in this case is +1. So the answer to number 6 then is going to be y equals 3x plus 1. And that's the equation for this purple line right here, and there's the y-intercept at +1. Okay, that's problem 6. Now, problem 7 is that applications problem, and there's a diagram that goes with that. So let me draw a sketch of that diagram before we get started talking about the problem here. 2,000, 2,200, 2,400. And we've got this point 0, 2,500. And then over here, we've got a second point where x is 5 and y is 2,050. Okay, so that's the diagram. The situation in the problem says a business purchased a computer in the year 2008 for $2,500, that's up here. In 2013, 5 years later, the computer was worth $2,050. This is the graph for the depreciation of the computer. 2008 corresponds to year 0, 2013 corresponds to year 5, and we want to write the equation for this line. Okay, so this is a lot like problem 4, where you had 2 points and had to find the equation of the line passing through those 2 points. So we're going to need to calculate the slope. So let's see, I'll start with the 2,500 on top, and then subtract the 2,050. And then if I start with 2,500 on top, I've got to start with the 0 on the bottom and do 0 minus 5. Okay, on the top we'll get 450, and on the bottom we'll get -5, and so our slope here is going to be -90. So that means the equation is going to be in the form y equals -90x plus b. And now I talked about this once or twice in class, and some of these problems, they just give you the y-intercept. And here it is right here, 0, 2,500. So I can just go in and put in 2,500 as the y-intercept, and there's the answer. Y equals -90x plus 2,500. Well, what if you don't recognize that? Well, then we can use that same process that we did in the other problems. So negative 90x plus b. Let's say we plug in this point for the x and y values. So the y is 2050. The x is 5. So that'll be negative 450. And then add that to the other side to get the b by itself. And so b is 2500, and that's just what we had. Okay? So if they give you the y-intercept, you can just go ahead and put it in. If not, or if you don't recognize it, you can always calculate the y-intercept by plugging in x and y values. Okay. Problem 8. Problem 8 is one of those solving a system of equations by graphing. So I'm going to need, so you'll have a grid on your test to draw your graph on, because that's really important in doing these problems. It can be really hard to see where their intersection point is if you don't have a good grid. And it's good always to indicate the scale of your grid. Okay, so problem 8. Solve the system of equations by graphing. So our system of equations is x plus 2y equals 8, and 6x plus 32 equals 4y. All right. So to graph these two equations, I'm going to put these into slope-intercept form. I'm going to get the y by itself. This one, pretty straightforward. All we have to do is divide everything through by 4. Y is going to be 3 over 2x plus 8. Okay? Let's take the other one. X plus 2y equals 8. Move the x to the other side. X plus 8. And then divide everything through by 2. So this one will be y equals negative a half x plus 4. All right, so now we've got both equations in slope-intercept form. This one has a y-intercept up at 8 and a slope of positive 3 over 2. So if I go up 3 and over 2, I can go down 3 and back 2 as well. And that'll give us a line that looks something like that. This one has a y-intercept at positive 4. And if I go up 1, I have to go back 2, up 1 and back 2. Or I can go down 1 and over 2. That line is going to go like that. And so here's the point that satisfies both of these equations. And like I said, it's kind of hard to see on this graph, but this is where x is negative 2, y is positive 5. And you can always double check to see whether or not that's true. If we go back to the original equations, let's see, x plus 2y equals 8, and 6x plus 32 equals 4y. Now let's see, if x is negative 2 and y is 5, is that going to be 8? Negative 2 plus 10 equals 8. There we go. Excellent. Do the same thing here. If x is negative 2, is y 5? Negative 12 plus 32 equals 20. Yep. Okay. So that's it for the sample test. I would recommend if you have any questions, right, about any of these questions, please let me know. I'll be happy to talk with you about it. Until then, I'll see you in class.